Record. So this is section 10.1, and we are simplifying rational expressions, or aka algebraic fractions. So when we started, let's do a quick review of simplifying a fraction. I could break 20 down into prime factors, and I could say, I usually start when I want to break things down into prime factors, 2 times what is 20? 2 times 10. And 10 breaks down to 2 times 5. So those are the prime factors. Right? And 24 is 2 times 12. And 12 breaks down to 2 times 6. And 6 breaks down to 2 times 3. So that's what it looks like when I break them down to prime factors. And when I'm in prime factor form, I can then cross-cancel common factors. Right away, we see we have a common factor of 2 that I can cancel out, and another common factor of 2. And so what's left in my numerator is 5, and in the denominator, when I multiply, is 6. Does anybody know what the GCF is? What's the GCF, the greatest common factor? Yes. 4, 2 times 2, right? Sometimes when I have big numbers, that's what I do. I divide both numerator and denominator by 2, and then I reduce it again until I get to something familiar. I just keep going by 2's. And if you multiply those 2's, that becomes part of the greatest common factor. So basically what we're doing is we're cross-canceling common factors, okay, out of the numerator and denominator. This is chapter 5, a review of chapter 5. When we first looked at this, actually back in pre-algebra, we had you break this down into prime factors. 5 times 3a's times 2b's, okay? Over the prime factors for 35 are 5 times 7 times a times b times b times b. And then my common factors were what? What could I cross-cancel? I can cross-cancel a pair of 5's. I can cross-cancel a factor of a. And I have 2 sets of b's that we can cross-cancel. And we're really left with 1's there where those disappear. But in the numerator, what I'm left with is a squared, and in the denominator, I'm left with a 7b. But this took too long. You don't have to write that part. This takes too long, right? Nobody wants to do this. This is what we teach you in pre-algebra, so you really know what makes up that numerator and denominator. The second thing that I showed you was when you get a fraction like this, separate your numbers and variables. It's really like 3 different problems. 5 over 35, right? And then I had my a to the 3rd over, this is all one, a, and then I had, you don't have to write this, and then I have a b squared and a b to the 3rd. And I said we can cross-cancel. When you cross-cancel, don't be lazy about your little marks. So we know that what goes into 5 and 35? 5. And I'm left with a 1 up top. 5 divided by 5 is 1. 35 divided by 5 is a 7. What's the greatest amount of a's we can take out? 1. I take out 1a here. I'm left with the a squared. And don't just get lazy and do this. If you do this, then what happens is sometimes people think that's a 2 left in the numerator. It's not a 2. What's left in the numerator? A squared. Right. So don't be lazy about your markings at what you have left. And when I take out a, when I divide an a out here, what's left? 1. Okay. What's the greatest amount of b's we can divide out? And I'm left with the number 1, and in the denominator, I'm left with b. So I multiply across, I'm still left with a squared over 7b. You guys with me? But then I got you to a point and I said to you, let's do the work right within the fraction. We don't need to, I can just say 5 goes into 5 1 time and 5 goes into 35 7 times. Greatest amount of a's, I can take 1a out of here and I'm left with a squared. I take 1a out of here, I'm left with 1. I take 2b's out, I divide 2b's out here, and I'm left with the number 1, and I divide 2b's out of here, and I'm left with, and so basically we're left multiplying all the way across, and I'm left with a squared over 7b.
You didn't cross out the B.
Okay, does that make sense? Okay, by now you should be able to do this. Cross-canceling these kinds of fractions. All right, I'd like to see you pause the recording and practice the next one on your own. Okay, start with number 1. Pause the recording. Bryce, what can I divide out?
You can divide out a 2.
And I'm left with in the numerator?
3.
And in the denominator?
5.
5. What else can I divide out, Eitan?
You could divide out the x.
And what's left in the numerator?
The numerator would have an x, and the denominator would have a 1.
A 1. And what else can I divide out, Carter?
A y.
And what's left in the numerator?
Y to the third.
And what's left in the denominator?
1.
Okay, and so my final answer, Carter?
3x y to the third over 5.
We just leave it like that. Okay, now what's different about this next problem compared to the last one? Dakota?
That it has plus signs in the middle of the equation.
Yes, and so what we have actually is a binomial. What we have actually is a binomial.
Why is it a binomial?
So now we were on to the next problem. So what we have are binomials. Now, the only way you can cross-cancel a binomial is if it looks exactly the same. You cannot, repeat after me, you may not take a piece of a binomial. Did it come out of your mouth? So the first thing we're going to need to do is factor. We factor our numerator, we factor our denominator, and then we see what we have. Okay, how can I factor the numerator? How do we factor that numerator? Go, Eitan.
You do the first thing we learned in factoring, and you see a GCF,
Which is
5.
5 times?
The quantity of x plus 2.
Good. So now that it's factored, I have a common binomial factor. Okay, a common binomial factor. So what would I do next? Yes.
You would cross cancel out x plus 2.
Good, and I am left with 5. Okay, so notice, I didn't cross-cancel the x's, I cross-canceled the binomials. You cannot take a piece of a binomial. Yes?
I did this a different way. I did it kind of like the way that we did before. And so I factored 5x over
You can't factor.
x.
Over.
Or I did whatever, I simplified. So like
You mean you
5x
cross-canceled?
Or cross-canceled.
You cannot cross-cancel a piece of a binomial.
I got the same
If
answer.
you do that, I promise you, you will fail the class. It will not work out for you. Maybe it works out in this one. Stop it, redo that whole, go back. We factor first, and you may not take a piece of a binomial. It will be the one thing that I promise you will not work out well for you.
I have a question.
Yes.
What if it was like, if you put the denominators, like if the first one was a 5x, or no, let's
You
make
cannot take a piece of a binomial. Let's go. Let's continue. Now, look here. Let's say, like, you would think that we'd be able to just do this, right?
No.
Okay. Cancel out the 3's? Well, we can't. But here we can because it's multiplication, right? Okay, so let's see why. If I replace that with an actual number, you're going to see that it will work when there's multiplication, but it does not work. So if we replace the x with a 4, is there a common factor of 3 in there? No. So it's not going to work. You can't take a piece of a binomial. But here, when it's multiplication, we can divide out that common factor of 3. Right? We know that there's a 3 inside the 12 and there's a 3 in here, and so it can be divided out. Yes? Yeah.
So if you have like that x plus 3 plus x over 3, it's kind of like
You're done. You're done.
it's like
You may only cross-cancel a binomial that looks exactly like the binomial. There's no exceptions to that. Okay, yeah.
It's kind of Bryce's question, but not really. What if it's like 2x plus 1 and then on the top, and then on the bottom it's just like x plus 1.
You may not take a piece of a binomial. You may not do this. No, you will get it wrong. It will make everything wrong. The only thing you may cross cancel is a 2x plus 1 over 2x plus 1. Okay? So now let's look at it. The first thing we're going to have to do when we have these fancy fractions, rational expression, is we have to factor our numerator and our denominator. How do I factor the numerator?
Difference of squares.
What is it?
Difference of squares.
Which is
X minus 5. The quantity of x minus 5 times the quantity of x plus 5.
x plus 5 times the quantity of x minus 5. And then in the denominator, how do I factor that? Somebody I haven't heard from? Go, Alan.
You factor out 5,
And what's left?
x minus 5.
Now, what can we cross cancel? What can we cross cancel? Go, Dakota.
We could cross cancel both of the x minus 5.
The quantity of x minus 5, and so what's left is x plus 5 over 5. Okay, I want you to take a moment, fully factor the numerator, fully factor the denominator, and see what you can cross cancel and simplify. Go. Pause the recording. For number 2. In your notes, you might want to say factor numerator on the left, factor denominator, then cross cancel. You explain the directions on the left side of your Cornell notes and the actual problem on the right. Okay, what's the GCF I can pull out of the numerator? Step 1 factoring. Go.
3
Times what?
x
Squared.
minus 9.
Good. Can that be factored further?
Yeah.
Okay. 3 times.
X plus 3 times the quantity of x minus 3.
Okay. I'm just going to kind of put that there. Now, what multiplies to negative 21 and adds to negative 4?
7 and 3. Negative 7.
Negative 7, positive 3. So that is, all right, just go here. Looks funky. X plus 3 times x minus 7. X plus 3 times x minus 7. Okay, what can we cross cancel? How about Roman?
You can cross cancel out x plus 3.
Good. And what's left in the numerator?
3 times the quantity of x minus 3
All over.
over the quantity of x minus 7.
Now, can I cross cancel the x's?
No.
Absolutely not, because it's a piece of a binomial. You may only cross cancel a binomial or trinomial that looks exactly the same. Are you guys good? Okay, questions? All right, moving on. All right, tell me, what is the opposite of, put your hand down, you haven't seen it. What is the opposite of 7? Everybody.
Negative 7.
Okay, what's the opposite of y?
Negative 1.
Opposite of x plus 3. Negative quantity times the quantity of x plus 3, or? Yep. Okay, we can do it either way. What about, remember we had y minus 8. How do I, what?
8 minus y.
Right, but it would be 8 minus y. We could, the negative times the whole thing. When I distribute it, I get negative y plus 8. But to show the opposite of this, I want you to write the positive one first and read it like that. Does that make sense?
Yeah, you want us to
Okay.
do that?
So what would the opposite be of 2x minus 3? Everybody?
3 minus 2x.
Okay. What's the opposite of 6 minus 5x?
5x minus 6.
Okay, what's the opposite of t minus 8?
8 minus t.
Now, we are going to rewrite this so that it shows a product of negative 1 and the opposite. So negative 1, and what's the opposite of negative m? So negative 1 times the opposite of negative m. Isn't that equivalent? Does that equal that? So when you're multiplying two opposites, it really means the same thing, right? Negative 1 times what's the opposite of d? Does that equal my originally what I started with? Okay, negative 1 times the opposite, which would be?
X plus 4.
Good. Negative 1 times what's the opposite?
3 minus b.
3 minus b. You get it?
Yeah.
What would the next one be? Somebody else? Raise, Cameron?
Negative 1 times 5 minus 2x.
5 minus 2x. How would I show the next one? Fatima?
Negative 1 times the quantity of 1 minus x squared.
Good. Everybody, how do I show the next one?
Do you have to write this?
Alex, how do I show the next one?
Negative 1 times 3 minus 7.
No, times the opposite. Have you not been with us? We've been doing everything opposite. Have you noticed? This is the opposite. 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 So what is the opposite of this?
7k minus 3.
Yep.
I thought we were writing that.
Negative 1 times 7k minus 3. 7k squared.
Number 5 is incorrect. There's only one parenthesis.
Okay. So questions? Yes.
On number 6, could you factor the difference of squares before you...
We're not asking you to do that. All it asks you to do is look at the directions. Okay? So don't go further when that's not asked of you. It's not asking us to factor. It's asking us to... Okay. Now, let's factor our numerator. What does this factor to? I would suggest writing this example down. And in your left, you're going to write factoring a negative 1. And on the right, you can add this problem. So how would I factor the first one? The numerator, just normal. Go, Bryce,
The difference of squares?
which would be
X minus 3 times the quantity of x plus 3.
x minus 3 times x plus 3. Okay, now, are you noticing that 3 minus x is the opposite? Do you see that? That denominator right here is the opposite of this numerator here? Factor. So we can change that. And we can, I probably would have done this all in one. So I would do x minus 3 times x plus 3. And then I'm going to factor out a negative 1. And what does it become? X minus 3. Now, what can we cross cancel? So the cross canceling is still, we only cross cancel what looks exactly the same. Factored the, I made it the opposite. Isn't this equivalent to this? Negative 1 times the opposite equals what I started with. So what's wrong, Rami? Okay. You want to try number 2?
Wait, can we just...
Oh, wait, we're not done yet. So let's finish it. And so in the numerator, we're left with x plus 3 over negative 1. We can show that as I can take the negative in the denominator or the numerator. I can write it like this. Or I can multiply it out and make it negative x minus 3. All of these are as fully factored as can be and are all solid answers.
So,
Okay? Any of those 3 are fine. Okay? Try number 2. Try number 2. And go. Pause the recording. I shouldn't really be teaching you to go sideways. You should be doing these up and down. But it's okay. You know, when we get to equations, they better be up and down. We're not going to go sideways with equations. Pause the recording and try number 2. Okay, so what multiplies to negative 30 and adds to negative 1? Go, Annabella.
Negative 6 and 5.
Good, and 5. So this becomes n minus 6 times n plus 5. And when I factor the denominator, I get 6 minus n times 6 plus n. What can I do to make that so I can cross cancel? The first one, we're going to keep it as n minus 6 times n plus 5. And what would I do, Dakota?
You could do negative 1 times the quantity of 6 minus n.
No, okay, but if I'm doing negative 1, I have to take the opposite. I can't just add a negative 1. I do the negative 1 means opposite, and the opposite of 6 minus n becomes? What's the opposite of this?
N minus 6.
N minus 6, because I did the negative 1. And then I have my n plus 5.
Oh.
Okay, oh, sorry, no, it's 6 plus n, sorry. I don't know where that came from. 6 plus n. And so now what I can do is cross cancel here. And I'm left with n plus 5 over 6 plus n, or we could write it n plus 6. Yes, question?
Doesn't that mean you're also multiplying 6 plus n by negative 1?
It's 2 times 3 times 4. Doesn't matter. It's like you're only factoring out 1. By the way, hold on. I want to show you something. Okay, so now look here. I can factor out of just this factor, right? So when I factor it, I'm going to put that negative 1 here. I'm still writing this one the same, 6 plus n. But what changes is that other one, right? I'm only taking the opposite of 6 minus n, which is n minus 6. Okay? If I take 3 opposites, it won't be back equivalent to what it was. But really, we're taking 2 opposites, so it kind of balances each other out. Yes?
Wait, so the final answer is n plus 5 over 6 plus n?
Yes.
Why?
So why did that negative 1 go away?
What?
Then why don't we use the negative 1 times 6 plus n?
I mean, you could, but we don't get rid of it. We can't get rid of it because remember, when I'm factoring, okay, I got to move on. I'm not going to get rid of it. I can multiply it in. I could leave it like that. I mean, just leave it like that. It's there. We pulled it out of a number, out of a binomial. It can't just disappear. Yeah.
I don't know if it's like wouldn't work for this one, but I did the opposite of both, so I did negative 1 times negative 6 minus n times the quantity of n minus
No, then
6.
you're going to end up getting it wrong.
No, I got the same answer.
Then you really didn't. You're really not taking it out of both, and you couldn't have. If you did it to both factors, you took 2 negative 1s out, you're really just you're only changing one binomial, because you said it was n plus 6. That's not taking the opposite. You wrote it, but it's not. Let's continue on. So here we're going to have some lead coefficient factoring, okay? Multiply the 2 times the 3. It's going to end up being, now what could I do? What could I do next? What's the opposite? Bryce?
If you multiply negative by the quantity of 1 minus x,
Not by, we're not going to multiply it. We're factoring it out of this term.
factor a negative 1 out of...
So 1 plus x stays the same. Here's what's changing, x minus 1. Okay, now I'm left with, now I could have factored the negative 1 up here and changed this. Do you understand? It doesn't matter where I do it. I think my PowerPoint does it there. They factor out of the numerator and flip the top one around. Shh. Okay, so now I can cross cancel and I'm left with this. I have a whole nother slide I need to get to. The next one, what's the GCF? Go.
2x
Times.
times the quantity of x minus 100.
Good. And that factors out to
It factors out to
x plus 10, x minus 10. Now, if that's the case, let's look at this. Now, when I'm doing this, remember there's a, I can divide a 2 out, and I'm left with this. I can divide an x out, because they're not part of a binomial. Okay, but I'm left with that -5. And then we can take an x minus 10. So do you see how I divided if I needed to flip that around, so I made that -10x. Does that make sense? Yes or no? Okay, and then my answer is, all right. Last thing I need to show you how to do. And we would multiply it out or take the negative in the denominator or the numerator, but not both. Okay, last thing I need to show you is domain. What is x allowed to be? Okay, because we are in fraction form, that means that there are certain rules for fractions. And what is it? The first commandment of math. Thou shalt not divide by 0. You can't have a 0 in the denominator. So they're asking us to do two things. Find the domain, what is x allowed to be, and simplify it. The first thing we do is we factor. Okay? This is the point you figure out your domain. Here, what is x not allowed to be?
X.
Set it equal to 0. X cannot equal 0. And here, what would give me a 0?
4.
But x can be any other real number other than that. You with me? Okay? X can be anything other than that. Don't cross cancel like my PowerPoint does. You find out your domain here right after factoring. Then cross cancel. Here's the simplified part, but here is the domain. Do you understand? Okay, one more time. Let's try it again. You factor first. At this point of factoring, before you cross things out, you figure out what's going to give you a 0 in the denominator. If x, you set both equal to 0, x minus 4 equals 0, so x would be 0, or x cannot equal 0, and x cannot equal 4. But it can be anything else. After you do that, then you cross cancel. Let's try the next one. I'm going to factor. Now, in the first term, what would give me a 0?
0.
Right. If x equals 0, 2x equals 0, right? If x is a 0, x cannot equal 0. And in this second term, what can x not equal?
3.
And so x is an element of the reals, but it can be a real number, but it can't be any real number except for 0 and 3. And then we can cross cancel. I'm recording. Okay, sorry. Okay, now I'm left with x plus 3 over 2x. Does that make sense? Because they're asking us to do two things. State the domain and simplify. So I'm left with x plus 3 over 2x. So we factor first, then figure out what x is not allowed to be, then reduce the fraction. Okay? Yes. Pause the recording, then try the next one on your own. Now check your work. X cannot equal -5, +5, or -2 is the domain, and my simplified fraction is x plus 2 times the quantity of x plus 2. That's the recording.